Welcome to another video and episode on my Raspberry Pi Model 1B, which runs Raspbian Linux and is connected to network, serial cable and band cable. Network cable for VNC and obviously internet. The serial cable for necessary connection to get VNC running and to check on errors if there are, and band cable to connect to this breadboard. Also Raspberry Pi camera, supported by some fischertechnik. The Raspberry Pi camera is currently running a video stream which is a few seconds delayed, but it's nice to have a different view from than the camera that you usually see. Anyway, it's programmed in a Python for the project to have sorry for shaking the camera a bit, to have control over this electronics. This is a MAX522 digital to analog converter, which is supposed to control this LED through SPI, serial peripheral interface, the 3-wire version of it. The SPI is also used for this chip, the MCP3008, which is an analog to digital converter. Focusing here, SPI has a few wires. It has clock, data and chip select. Chip select is to select which client, which chip you want, obviously. Data is for master output, slave input, master input, slave output. For full SPI like this one, you have both separate. So you have, in terms of direction, bidirectional. Which is also called full duplex, and this one only has has both connected right here. A band staple improvisation, connect them both, and that is why everything is now half duplex. So it goes via data in, this wire ending up here is going half duplex, so in and over the same wire out. Does it work? That's another question. Last time I noticed that the LED was burning like it is now, but program is running, and the probes are connected to oscilloscope to check the signals, and that gave a little problem. On screen, which you will see soon, I have the Pi scope, which is a software scope, software oscilloscope, which can see the signals from one side, from the internal side of the GPIO, general purpose input output, which is this actually. And the oscilloscope looks at it on this side, the hardware side. Anyway, enough introduction. Let's see how things run. And now the LED should start burning, which it already did. So let's take a look at the software. And having started the program, you want to see this running. you want to see this running. And yes, this is from the Raspberry Pi camera, raspicam. What's not okay with it? Well, basically, looking here, it doesn't show a thing. Absolutely nothing. Nothing here, nothing here. What the cause here is, I don't know. What the cause here is, let's try another setting. But on the other hand, when there is nothing to be seen here, I better restart the program, that is. Now I see something, and yes, now I see something here as well. So why the first time not, I have no idea. So let's start again, because I see no signals anymore, not on the oscilloscope anyway. I see absolutely nothing. And timing doesn't matter, it seems. Time base. And these signals mysteriously keep restart itself. Now the point is that this probe is connected to data in. So this should be the same as here. But is it? I saw something of data. Yeah. Right, I do see something of data. So, and on, I should see it here on the blue line as well. Yeah, I do. So then it is time to move the probe to input, not to output. And that's the strange thing. That is a continuous output. So why is this output continuous? Another thing is, what does this do? This is output B. It's flat. Well, let's connect it for a while. It stays absolutely flat. So let's get back to this one, output A. So this mystery is still unsolved. Then the other question may be, what am I doing wrong here? Because I am doing list 3, which is gradually expanding, gradually increasing numbers from 0 to 0F. No, from 00 to F0. And with an increasing value, you would expect to have a bigger, a brighter burning LED. But does it? Not with this line anyway. Or is it too am I doing it the wrong way? Could be too. I'm going to rewrite the algorithm and divide it in parts. I think that's a better idea. So what I will do is divide these into a few lists. So this will be list 3, and by the way it's pronounced lijst, but that's detail. And 5. No. And then which is 6. Alright, so now we have this. We start with 3. Yeah. And after 1 second we say SPI dot transfer. One dot 4 time dot sleep 1 and repeat. And so this is until 6. No, up with 6, 5 and 6. Let's see if there is any difference at all. Of course I have to cancel this. Now a nice big question is, why is this signal, which is currently output, not changing? What does it, what is it affect when I pull this wire? And let me show right here. So when I pull this wire, which is data in, what happens with the oscilloscope image? So let's see. It has no data in at all. Now this is weird. Mosi and Mosi Master input, slave output, master output, slave input are acting up. But still not over 12,000 milliseconds, 1200 milliseconds. Why? What is this crazy thing? Okay, let's start again. Oh yeah, right. List doesn't matter, should be removed, but what is the actual effect? If there is any. Okay, I'm doing something different. No, be careful. Line 3 is then this one, and alright, let's try again. What, if any, is the difference? Right, if I now rethink how a binary would count, then I would have to scratch out a couple of numbers, because it's 0, 2, 4, 16, 23, 64, 128, 265, 256, not 265, 256, yes, and those are not in. So it might very well be that these values are not doing exactly what I expect. On the other hand, I didn't see anything about this one. Anything happened to here. So what is going on? According to datasheet, the input is 1 byte. This is 1 byte. So what uses it to send 4 bytes? Not really much. 16 you won't see, 32 you won't really see, half you can see. So what good is it to use it like this? Right, I'm gonna scratch this. Then 64, yeah. 128, yeah. 256, that is 255 actually, which is FF. So let's see if that is working out with time sleep of 1, which brings the question, what is 1? Is that indeed 1 second? We'll see. Let's go. Oh wait, let's scratch the confusion. List is out. Start. Why don't I see everything? I see virtually nothing on . I need to see signals as frequently. Okay, let me go to the smallest time base, which is 5 nanoseconds. I see nothing. Going back step by step, but still I see nothing. Yeah, I see something, but this one is still wrong. When do I see a signal? Okay, quit. Go. I don't see a thing. So, well, here something is being sent, no doubt. And 1 is really 1 second. And this is off and on. So, but why, if I see this, I should see something here, which I barely do. So why is that? I don't even have to look at the LED, although it is burning, more or less. It doesn't work out. And there's some instance somewhere. Why is that? Should I cycle power? When I look at this, power is almost off. I cycle power to the chip. Oh, look at this. Now it has two strange items. Why? Oh, one. Okay. But still, what's going on? I fail to see what is up. Alright, another one. No signal whatsoever. So how can I measure what's going on? I see something on the GPIO, but that's not enough. Time is almost up, but I want to do something different, a little bit different. The data channel, which is this one, and let me show the entire image, which is this one. I want to connect it. Okay, push it entirely in the breadboard, this one, and then have it connect to this one, where it all connects. So what's the difference? A permanently high signal, and this is gone permanently low. What is the difference? Right. I disconnect it here and I reconnect, and oh wait, that is another point. If I take this away and I reconnect, where? I reconnect right here, and I reconnect this one right here. So it is clear that which one is it anyway? Now I have to look for the wire, which is which, and the wire it is now connected to is wire 19. Wire 19, which is data in. Data in is permanently high. When I stop the program, what does it do? This should stop. Does it? No. When I connect This one, I have to be careful not to rip anything out. Now it is low. What is the difference? It is output 21, which is data out, which means that it goes towards the Raspberry. Now here things don't really make up. And really in this situation I found the data. But still still nothing. So back to where I started. Nothing really. Alright, a short wrap up. Signals here are nice. Do what they do. Signals here, for some reason, not. Why? I have honestly no idea. So for now, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Twitter and Instagram. Please donate to keep videos coming to you. Show your appreciation. Very much appreciated. And you can donate via PayPal and Wired. You can also become a patron and have your name mentioned. Will be mentioned on my website, and depending on the pledge you make also with my videos. For more information, see my website under this video. And well, this is obviously going to be continued. Have a nice day and bye bye.